Hi everyone, my name is Abel Gray Cantoma. I'm from GREYTEST CAD Design Concept. This is my WhatsApp contact. You can reach me on this number, or you can even call me, okay? Now these are the list of softwares which I have covered on our YouTube channel. They are very much available on that channel. Visit the channel and actually keep yourself busy, okay? Today I'm going to be showing you how to I'll be giving you an overview of how your slab is like in your RCDC, that is in your Staad.pro. Okay, so I'll be taking you through that process right away. If we go to recent project, let's look at slab. Like I said, this is just an overview of how it looks like. Okay, so as we proceed further in the next set of series, I'll be taking you through the process deeply, where I'll be giving you more details about how to actually come about your detailing in RCDC. Okay, if you already love what you're seeing, make sure that you like this video by giving it a thumbs up. Okay, just click on the bell icon so as to get a notification whenever I post videos. I post videos like these on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Make sure you click on that red button written subscribe. Once you click on it, you have subscribed already. It's actually 100% free. Okay, now you can see this is the output, and then this is actually our input. Okay, from when you were actually specifying your sections, you are defining your materials rather. When you define your materials and then the sections, okay, of your structural member, there you have actually specified the thickness of your slab, and then the characteristic strength of the concrete and the characteristic strength of the steel, and then the concrete cover and all that. You must have done that in your design. Okay, so here is actually, in this place we actually bring out our structural detailing. Okay, you must have done all your analysis and your design there in the Prota structure, in the Staad.pro rather, please, I'm sorry, in your Staad.pro, and then here you can actually print out your detailing. And then the good news is you can as well import your analysis from eTabs as well into your RCDC. Okay, amazing, right? Another good news I have for you is this: I now have the solution to your Prota structure steel, that is your Prota steel. Okay, I believe a lot of people have been having issues with their Prota steel. I now have that complete solution to that. You can get Prota structure complete from me, and then the steel is actually working perfectly from me. Okay, you can just DM me, or you can even call me on this number. Okay, now if you look at this, you can see this is actually our inputs. You can see this is slab 1, that is panel 1, panel 2, panel 3, panel 4. Okay, so you can play around with this. You can even change the name. Instead of S, is going to you can rename it to P. Okay, but I'm going to leave it just as it is. Now you can see from here, this is our panel 1. If you look at this, this is your slab 2, that is panel 2. This is panel 3. This is slab 4. Okay, like that up to this point. Now it tells you if this is a one-way or a two-way. You can see this is actually a two-way. This is an indication showing you that it's actually going in two directions. This is one direction, this is second direction, so it's going in two directions. So that means our reinforcement will be provided, our main reinforcement, along this direction, Y direction, and along X direction as well. Okay, which I have explained vividly in my RCD 2000 training. Okay, you can go down below the description of this video. You find a link to my YouTube channel. Make sure that you visit that YouTube channel. You find a whole lot of great things about design. Okay, that will take you through the process, even as a beginner, even up to mastery. Okay, you can learn from us on our Telegram platform, where we teach, we give you the software, we guide you through the process of design until you attain mastery. Okay, all you need to do is just to DM me. Now you can see these are different slab. These are panels. The panels are up to 24, if I'm not mistaken. Yeah, this is 24. So this is, the panels are up to 24. This is a two-way, this is a two-way, this is one way. One way is when you divide your ly over lx. Your ly is actually your long span from here to here, divided by your lx, which is the short span. Okay, that is how you get to know whether it is actually a one-way slab or a two-way slab. Now when you divide your ly over lx and then it gives you the value which is greater than 2, what that means, it has become a one-way slab. That means your reinforcement will be provided along the short span. Okay, let me give you a perfect example. If you divide a 4 divided by let's say 1.5, okay, definitely your value is actually going to be greater than 2. So in that case, that slab will definitely be a one-way slab. But to have a deeper insight, like I said, make sure that you visit my channel for that. Now this is panel 2, this is slab 3, slab 4. You can see as I'm clicking, the red indication is actually changing position. Okay, you can see formerly here was actually shaded red. So you can see as I'm clicking, it's taking us to where that particular panel is. Now this is actually the output, because this is actually your input. This is what we have actually imputed into this software, and then this is the result is actually giving us, which is the output. Okay, this is actually the output. Okay, this is actually the input based on your specification in your, when you were defining your structural member, like I said earlier on. Okay, and then this is now the output. Now you can see for slab 1, the thickness of that slab is 175. Okay, that is your panel 1, 170 for panel 2, for panel 3, 170, 22. Okay, so you can play around with it and then make it a uniform thickness of slab, because of in construction process you may have difficulty in changing thicknesses of your slab. So you can use a uniform thickness that will actually make your work much more easier and then faster. But there are cases where you have where your deflection is actually going to be insufficient. In those particular panels, you can actually increase the thickness of that panel. Okay, I have explained all of that in my YouTube channel. Make sure that you visit them and then keep yourself busy. Okay, you can see this is actually the grade of concrete. This concrete grade is 25 all round. Okay, and then the grade of the steel is actually 415. Sorry, like I said, this is just a sample drawing from the RCDC itself. I did not actually do this design. I'm just explaining to you how this your detailing appears in your RCDC. Okay, so in the next series of our training, I will be taking a live project and I will do the design and I will do the detailing here, and then you're going to see how it's going to look like. Okay, so you can see your bottom at X, that's your short span, is Y8. Someone was actually asking me what is the meaning of T. Okay, T actually means your thickness of your reinforcement. Okay, so T8 is actually the thickness. So the thickness is 8, okay, which is 8 millimeter. That is the thickness of that particular reinforcement is 8. Okay, but in some countries we actually use, like in Nigeria, we use Y8. That's is a high yield steel. Okay, for reinforcement. Now this is Y8 at 110 mm center to center. That is the spacing. Okay, this is also like that. For your ly is Y8 at 175. Okay, so you can see there's a whole lot of difference in the spacing, in all of the spacings, which is actually sometimes may be difficult while you are on site to keep changing your spacing. Okay, so but for economical purpose you can actually maintain that, but to save time, and you can actually use a uniform spacing that will be safe and also economical as well. Okay, but in your design, one thing you must always put into consideration is your safety and economical. Okay, safety first, okay, before you consider the economical aspect of it. Okay, ly. Then for your top we have this. Okay. Okay, so if you have been following me, I believe you should understand all of this that is here. Okay, now good. Now modify, we go to your design. Okay, you can see here we can actually modify all of this. Okay, you can see here. Now we are on slab 17. Okay, this is the one we are highlighted, and you can see this is actually the one that is actually here. So just in case, you know, you may have a two-way slab, and then you may want to design it as a one-way slab. Okay, because or you may have a one-way slab in some cases, and you may want to design it as a two-way slab. For example, if you visit Victor Oyenuga RCD Reinforced Concrete Design Book by Victor Oyenuga, when you have a one-way slab, in a case whereby even the short span is actually up to 4 meters, it is advisable professionally to actually design that slab to be a two-way slab. For example, if you have 12 by 4 meters, for example, okay, you know, when you divide 12 by 4, it's actually going to give you greater than 2. Okay, so in that case, because the short span, which is up to 4 meters, you will have to design that particular panel as a two-way slab. I'm just giving you, citing an example. Okay, please don't crucify me for that. Okay, but that is just how it is professionally. Okay, so from experience rather. Okay, so that's the point. Okay, so if I actually switch to another slab, the same way I'm going to see that too. I'm not modifying anything here. Modify drawing style. You can actually modify the style. Okay, how you actually want your labeling should look like, and the text height. You can see section label. I can increase the label of the height. Okay, your text height. If you are used to Microsoft Word, you know, you can play around with your text height. Okay, that is exactly what is going on here. And then your text and all that, you can see the elements, main labels, support labels. Okay, schedule, the headers, schedule text, and then your dimension text. Okay, just in case sometimes you may want to print, and then you see the dimensioning is actually very small, and then you may want to increase that from here. And then your drawing unit, you can see we are using a metric unit, which is in mm. You can actually switch this to imperial unit. Okay, that is in your inches. Okay, you can actually switch that to I think that is the American unit. You can switch to this. Okay, so you can switch to whatever units of measurement that you actually use in your country. Okay, so as for me, I prefer to use the metric unit. Now you can see the level mark, section mark, grid mark, scale mark. Okay, all of this you can play around with that too as well. I don't want to save this. So I'll close this. I've gone through this. Importing drawing style. You can actually import a drawing style, which I'm not going to do that right now. General arrangement plan. Okay, general arrangement means your structural layout, that is your arrangement of your columns, your beams, okay, your slab. This is where you actually determine how many number of columns you want to use in the building, how many number of beams you want to provide in the building, considering the safety and then the economical aspect of it. Now you can see, for example, if you look at this, if I zoom here, you can see here on this beam, you can see this beam is actually resting directly on this particular beam. Now this is actually a primary beam, this is actually a secondary beam. This is also a primary beam, while this is a secondary beam. Now you can see this beam is resting directly on this beam. This is also resting directly on this beam. Now this beam is actually a support to this beam, so it's not resting on a column. Okay, so this beam is actually acting as a point load on this beam, acting as a point load also on this beam. Please, I will advise you to lay your hands on my RCD 2000, which I have covered. I explain all of this vividly in my RCD 2000 training. Okay, so you can go through that now. So that is actually what it means by general arrangement. So you may not want to provide columns everywhere. It may not be economical, you know, providing column everywhere. And then there are cases whereby you may not want to play around, or you may not want to tamper with the architectural drawing, because in the architectural design this particular area might actually be an opening, maybe like a door. Maybe a door is actually around here, so definitely when you place a column here, it will become an obstruction around that area. So you have to devise a means of providing a beam without providing a column around that area. Okay, so it takes a lot of experiences and a lot of training from professional in order for you to understand this proper. Okay, so let's go back here to you can check my in-plan detailing. Let's look at that. Okay, now you can see this is actually your in-plan detailing. You can see your reinforcement that was actually provided. You can see these are reinforcement provided, Y8 at 140 center to center. You can see this spans from here. You can see a tick dot on this. This is the reinforcement. Now it's telling you that this reinforcement spans from here to here at then the thickness of the reinforcement is Y8 at 140 spacing center to center. Okay, so I can take off this. Okay, now look at the top reinforcement. You can see this is for your top bars. Now you can see this is the reinforcement that comes across. Your top bars are actually provided around your internal beams. Okay, now they are provided around your internal beam. Now you can see we have a top distribution bar, which is this. You can see we have it at 1310. You know, normally you have a return of 1/4, okay, in your slab, where you have 1/4, which is your return. Okay, so you have a reinforcement that is distributed across this reinforcement that actually returns into the slab. Okay, I have explained all of this too in my slab detailing. Okay, so we'll go deeper into this once we start we take a live project. Okay, and then sorry, this is not a okay, this is a slab section. Let's look at this. Okay, so you can see the beam size. This is actually for staircase elevation. Okay, so you can actually design this. All you need to do is specify the number of risers, okay, number of threads, and then the span, the height. Okay, this is the height at which the staircase is going. Okay, let's say it's going you know, standard height normally for residential building is around 3 meters. Okay, and then the bottom landing, and then all of this thickness you can as well play around with it. Now it's based on the architectural design. Okay, how the architect provides the staircase. So based on the architectural design, that is actually what you maintain here. So the architect might provide the thickness of your riser to be 150. You have to maintain it here. And then if your what do we call this, your thread, okay, or it's the spacing or the dimension of your thread, you have to maintain that too as well. Okay, so I'll take that off, and then let's go here to our report here. I'm still okay. I'm at report. Your project setting. You can see here we'll have cantilever 7, simply supported 20. Now this is your slab slash the depth, okay, your span slash depth, okay, which is for cantilever is 7, for simply supported is 20, for continuous. I have explained this vividly too on my RCD 2000. I explained this very well. You can see the concrete cover here is 20. This is actually a summary of what was specified in the design, okay. So you can actually change some of these values too as well to suit what you actually want to achieve in your design. Design summary. So this is your slab design summary, just giving you a brief summary of what was provided in your design, okay. So you can see all of that. You can as well even print this and then submit to, you can attach it for your approval, okay. Yes, so this is actually for your bill of quantity. If I click on OK, it will take us there. So let's say you want to see, you can go to the bar bending schedule setting, and then you can change some of these values here. It will actually affect how your schedule is going to be provided. So here, if I click on generate, it's actually going to generate. You are going to see your reinforcement and then the schedule of that your reinforcement, okay, that was provided in your slab design, or in your slab detail rather. Okay, now you can see this is actually our slab detailing that was provided, and then this is actually the bar bending schedule. This is actually how it looks like. Amazing, right? It's actually great. I actually love this software. Staad.pro is actually one of those popular softwares, internationally recognized, okay. So I would advise you as a designer, okay, as an engineer who actually wants to go into design proper, you should actually lay your hands on Staad.pro. It's actually great, okay. Okay, so let's go now into the footing briefly. We'll go to recent. Let's go to footing design, okay. Look at one here. I'll take you through that. Okay, now you can see your footing. This is actually our input. Okay, now this is based on the loading coming from the highest floor down to the ground floor, okay, down to your substructure, okay. The whole loading, you know, normally your loadings are distributed from your slab. It takes it down to your beam will distribute the load to your column will now distribute the load down to your foundation, okay. Usually it starts from the roofing will take it down to your roof beam takes it to your column, okay, and then you have your slab on the normal floor, which has a slab which distributes it to your beam will takes it to your column will now takes it down to your foundation. So that is why you see the columns are actually listed here too as well, and then the size or the loading that each columns carry will determine the kind of footing that actually will be provided, okay, because like I said, it designs for you based on safety first and then economical aspect as well. It puts the economical into consideration too as well. Now you can see this is actually our inputs. Now if you look at this plan, you will discover the columns are what were provided here. Now if we go to our output here, you will see that the sizes of these columns of your base are actually different from each other. If you look at this, if you even use the rule of thumb, you will discover that this column is actually biaxially loaded, this column is also biaxially loaded. What that means is that it's carrying only this load along the span, half of this is also carrying half of the load along the span. Okay, so it's actually not carrying load as much as the column, as much as the one that is here. So the column here is actually definitely carrying a higher load than the column which is here. So definitely, even if you discover the base are actually different, there are cases where you may even have this column being of different size. Okay, so if you look at the one that is actually axially loaded, which is this column 14, you can see it carries more critical load than any other column that is actually in your design entirely. So this column is actually carrying a more critical load. Okay, so these and these are kind of identical, they are carrying similar load. This you can take out your time and study this. Okay, if you have the RCDC, just go through these samples I'm actually explaining here. You will understand the points I'm actually trying to make here. So you will discover that they are carrying a similar kind of load. So you discover that even their base are almost or are of the same size. Okay, and then the column size will most likely even be the same because it's carrying actually a similar load. They are mostly axially loaded. Most of them here, these are actually almost of the same size. So they are carrying loads in 4 different directions. Look at this, and this. Here too, this. Okay, so it's actually very critical. Okay, so if we go to our view modifier here, we come to our design, you can see this is the design based on that particular column which was highlighted here. Is actually our column 1 or our base 1. Okay, if you come here, sorry, where am I? Okay, go to detail, we're going to see, so it's giving us the detail of this. Okay, you can see it's 2500 by 2500, and then the depth of that footing is actually 625. So this is 25 by 25 size of base. Because if you can remember, the floor is actually 3 suspended floors, so we have 3 floors up, then 1 ground floor, so it's actually 3 suspended floors, so it's actually going to be very, very heavy. Okay, so the loadings are actually heavy, so definitely the size of the base will most likely be as wide as that, and then the size of the column will definitely be large too as well, because it's carrying a very heavy load. Okay, okay, ignore column, rename column. You can actually rename top to bottom. You can rename your column, let it be from bottom to top. Okay, what else? Now if you look at this, you can see this size of this column here. For this, your base here, which is here, is actually 2500 by 2500, and then the depth is actually 625. Okay, this is 2850, and then by 900. Okay, which is okay. Now let's go to edit footing mark. You can actually edit the footing, so I can make it P1, or sorry, BS1. I can BS. Okay, so it depends on what you feel you can use that will make it much more, or it depends on how you actually want to present your design that will be easy for whoever is supervising that project to interpret. Okay, so for easy interpretation, or you can maintain this if you believe you can understand it perfectly as it is. So but the F means footing, but you can change it to BS, that is base 1, base 2, base 3, base 4, base 5, like that. You can actually change all of that, okay, to suit whatever for easy interpretation, okay, how you feel you can actually easily interpret that drawing. So design calculation, so you can check your calculation for each of the footing. So for footing 1, so you can see this is actually your design calculation for your footing 1. This is actually what you can actually print for approval. Okay, you can print this for approval. Okay, so you know, you have to actually attach your calculation to that. Okay, so it's one of those things that you must provide. Okay, so I'm just actually giving you an overview of how all of this looks like. So if I click on this, I just want to view the detailed drawing for my footing 1, that is my base 1. Okay, so it depends on whatever you actually want to. So I can play around, fixed distance, factor, this. I can play around, I can change all of these values to whatever suits me. So I'll click on OK. So you can see what we have here. So it tells us the size of each of this. It's actually different from this. You can see this, the size are not specified here. So let's come here and see this. You can see this is even up to 3,900, which is more than the size of a normal room. Okay, sometimes our rooms are not even up to 3,900 the size. Okay, okay, so let's see our bill of quantity. You can take our time and then look at all of that on your own if you have this software. If you don't have it, you can DM me, you can get it from me as well. Okay, and also the training as well, you can get it from me. So you can see here what we have. This is bill of quantity, BOQ summary. Okay, so this is summary. Okay, concrete units of quantity. Okay, so subtotal here, the rates 6,500. You can change all of that, okay, based on how you pay for each of this service in your country. Okay, so you can play around with it. Now let's go to generate BBS, that is your bar bending schedule. Good. Now you can see this is our footing. We have T3, T10 at 2,230. Okay, we have B1, that is base 1. T4, so this is Y12. Okay, it spans from here to here at 115. Okay, center, this is at 115, not center, sorry. This spans from This is the actual reinforcement. This spans from here to here at 110. Okay. And then we have this. Okay. So this is B, this is T, okay, which is our top. This is actually our bottom. This is bottom 1. This is bottom 1. That is our B1, okay. And then this is our B2. This is bottom 2. This is bottom bar, okay. That's what it means, bottom bar 1. So it's just a numbering. This is bottom bar 2, okay, in that way. And then it's just a numbering. Okay, you can see here we have, this is the cross section. Okay, your 150 tick. Okay, this is your blinding. Okay, it's 150 thickness. Yeah, you can see. So this is cross section of that reinforcement. Now you can see here we have your top. Here we have the bottom here. Your top is 10, your bottom is actually 12. Okay, so and then this is the schedule. So if you love what you're seeing, why not like this video? Make sure that you actually give it a thumbs up. Subscribe to this channel. It's actually 100% free. Click on the bell icon so as to get a notification whenever I post videos. I post videos like this on a weekly basis, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Make sure that you stay safe and make sure that you stay blessed. On the next set of series, I'll be taking you through properly how to actually run this detailing yourself, or picking a live project. I'll show you our pile cap detailing as well in the next episode.